Children, we are going to study about ionic compounds and electrical conductivity. Here is an experiment. Solution of 1 gram of sodium chloride is prepared in 50 ml of water. 1 gram of sodium chloride is taken and it is dissolved in 50 ml of water. Two electrical wires are taken and they are connected in this way. One end of connecting wire is attached to the negative terminal of the battery through one switch and one holder with an electric bulb. The insulating cladding is removed from the free ends of the two wires, and then salt solution is taken into a beaker and these wires are dipped into this solution, and then current is switched on and you have to observe whether the bulb glows or not. The same experiment, same procedure has been repeated by using different solutions. For example, copper sulfate aqueous solution, then glucose solution, urea solution, dilute sulfuric acid and dilute sodium hydroxide solution. So whether the bulb glows in all these solutions or not, that has to be observed. What is your observation regarding this experiment? The bulb will glow in in the solution of copper sulfate, in dilute sulfuric acid solution and in dilute NaOH solution. The bulb will not glow in glucose solution and urea solution. Why is it so? That reason we have to study now. Solution of 1 gram sodium chloride, common salt, is prepared. Take two electrical wires, connect one wire to the positive terminal of 6-volt battery. In this diagram, 6-volt battery is taken. One end is connected to the positive terminal of 6-volt battery. While connecting the other wire to the negative terminal of the battery, include one switch and one holder with an electric bulb. Remove the insulating cladding from 3 cm portion of the other free ends of two wires. Take the salt solution in 100 ml capacity beaker and immerse the uncovered ends of the two wires in it, keeping the wire erect with the help of support. Switch on the current, note whether the bulb glows. Repeat the same procedure using solutions of 1 gram copper sulfate, 1 gram glucose, 1 gram urea, 5 ml dilute H2SO4 and 5 ml dilute NaOH, each in 50 ml of water. Record your observations in a table. Do not forget to clean the beaker and uncovered part of the wires with water every time you change the solution. Means whenever the solution has been changed from the beaker, the care has to be taken that the wires, uncovered part of the wires are to be wiped out with help of water, and then it has to be cleaned every time. So the bulb will glow only in the solution of copper sulfate, sulfuric acid and sodium hydroxide, and the bulb will not glow when glucose solution and urea solution is taken in a beaker. Clear? The bulb glows only when electric current passes through it, and this can happen only when the electric circuit is complete. In the above activity, the circuit is found to be complete when aqueous solutions of sodium chloride, copper sulfate, sulfuric acid and sodium hydroxide are used. It means that these solutions are conductors of electricity. Electrons conduct electricity through electrical wires and ions conduct electricity through liquid or a solution. So, carriers of electricity are electrons and ions. Here, sodium chloride solution, copper sulfate solution, sulfuric acid solution and sodium hydroxide solutions, they dissociate in water, and dissociated ions are responsible for conducting electricity through the solution, and therefore the bulb glows in all these solutions. Electrons leave the battery at the negative terminal, complete the electric circuit, and enter the battery at the positive terminal. When there is a liquid or a solution in the circuit, two rods, wires, or plates are immersed in it. These are called electrodes. Electrodes are usually made of a conducting solid. The electrode connected to the negative terminal of a battery by means of conducting wire is called a cathode, and the electrode connected to the positive terminal of a battery is called an anode. So how the electrons are moving? Electrons are moving from negative end to positive end of the electric circuit, and conventionally current flows from positive end to negative end of the battery. Cathode is the negative terminal of the battery. The electrode which is connected to the negative terminal of battery through conducting wire is called as cathode, and the electrode connected to the positive terminal of battery is called as anode. So children, if I ask you, cations are positively charged ions, you know very well. So cations will move towards cathode or anode. What is your answer? Cations are positively charged ions, so cations will move towards cathode because cathode is negative terminal. And anions are negatively charged ions and they will move towards anode, positive terminal. Is it right? So the solution which contains dissociated ions are only capable of conducting current. Dissociation of ions and electrical conductivity. In the above activity, it was found that the aqueous solutions of the compounds sodium chloride, copper sulfate, sulfuric acid, and sodium hydroxide are electric conductors. Out of these, sodium chloride and copper sulfate are salts. Sulfuric acid is a strong acid. Sodium hydroxide is a strong base. We have seen that salts, strong acids, and strong bases dissociate almost completely in their aqueous solutions. Therefore, the aqueous solutions of all these three contain large number of cations and anions. NaCl, aqueous solution of NaCl gives Na plus as a cation and Cl minus as anion. Copper sulfate Cu2 plus and SO4 2 minus. H2SO4 dissociates like H plus and SO4 2 minus. NaOH will dissociate as Na plus cation and hydroxide ion OH minus as anion. So all these solutions contain large number of cations and anions, and they are carriers of electricity. So there is a relation between dissociated ion and electrical conductivity. More is the number of dissociated ion, the current will naturally, strength of the current will be more. Dissociated ions. Here negative electrode, that is cathode, and here cations are attracted towards cathode. This is the anode. Anode is a positive terminal and towards it anions are getting attracted. There is a mobility of positively charged cations towards negative electrode or cathode, and on the other hand negatively charged anions, they move in the direction of anode, and this movement of ions in the solution towards the respective electrodes amounts to the conduction of electricity through the solution. So from this it is clear that those liquids or solutions which contain a large number of dissociated ions, they are only responsible for conduction of electricity. A characteristic of the liquid state is the mobility of its particles. Due to this mobility, the positively charged cations in the solution are attracted towards the negative electrode or cathode and move towards the cathode. On the other hand, the negatively charged anions move in the direction of anode. The movement of ions in the solution towards the respective electrodes amounts to the conduction of electricity through the solution. From this, you will understand that those liquids or solutions which contain a large number of dissociated ions conduct electricity. Is it clear to you all? Actually, dissociated ions are responsible for conduction of electricity. Salts, as strong acids, strong base, they are giving large amount of cations and anions, and these ions are capable of conduction of electricity. Thank you.